You've been there, right? Stuck behind a self-driving car that just seems a little lost. It's a perfect example of a huge challenge we're facing. Our roads aren't just about rules, they're about social cues. So the real question is, can we teach an AI to drive less like a robot and more like a smart, cooperative person? Let's get into it.
So first, let's break down why these cars can feel so, awkward. It's not that they don't know the speed limit, it's that they don't get us.
I mean, just picture a typical four-way stop. For us, it's like a quick, unspoken social dance. Who got here first? Is that driver waving me on? Are they making eye contact? But for a robot car running on pure logic, this moment can be paralyzing. It can get stuck being too polite, or worse, make a move that's just dangerously wrong. And really, the whole problem boils down to this. On one hand, you've got the official rules of the road. Speed limits, stop signs, stuff an AI can learn perfectly, no problem. But on the other hand, you have the unwritten rules, that whole social agreement we all follow when we drive. And that is incredibly difficult for an AI to learn, because it's all about intuition.
And hey, this isn't just a random thought. It's the exact problem that researchers are trying to solve. This quote from the research paper we're digging into today says it all. The real world is a mixed traffic environment. It's messy, it's unpredictable, and it's full of humans like us. That's the puzzle.
So how in the world do you solve a puzzle like that? Well, the big idea here is to stop trying to train cars to be perfect lone wolves and start training them to be really good teammates. See, the old way of doing this was to have each AI learn all by itself. It basically treated every other car on the road, including yours, as just another moving obstacle to get around. But the new way, the one we're talking about today, is to have them learn together as a group, to actually figure out how to coordinate with each other. Now, the fancy technical name for this is centralized training with decentralized execution, or CTDE. I know it sounds super complicated, but the idea behind it is actually one you already understand. Just think of it like coaching a sports team. And this football analogy makes it super clear. During team practice, which is the centralized training part, all the AI cars get to see the entire traffic situation, like a team reviewing game film. A central coach gives them feedback on how they did as a team. But then it's game day. That's the decentralized part. Out on the road, each car has to make its own calls based only on what it can see around it, just like a quarterback on the field. Okay, but for this teamwork to really work, the researchers had to give the AI a kind of coordination superpower. The full system is called CMARL. That stands for Coordinated Multi-Agent Reinforcement Learning. And that word right at the beginning, coordinated, that's the secret sauce. And that secret sauce is a tech called Graph Attention Networks, or GATS. This is the absolute game changer. It basically lets each car understand its relationship with all the other cars nearby. It helps them figure out who's important to pay attention to at any given second. It's almost like a live social network, but for cars on the highway. To put it simply, this tech gives the AI something that you and I use every single time we drive: selective focus. Think about it. Without this, a car is completely overwhelmed, trying to track every single vehicle around it with equal importance. It's just not efficient. But with selective focus, the car learns what actually matters. It learns to pay way more attention to the car that's aggressively merging into its lane, and a lot less to the one that's just cruising 3 lanes over. It learns how to prioritize. So the theory is fantastic. The tech is cool. But does any of it actually work in practice? To find out, the researchers put these AIs through the absolute ultimate driving test. And they did not go easy on them. They built 6 of the absolute toughest driving scenarios you can imagine. We're talking tricky merges, chaotic roundabouts, dense highway traffic, basically every situation that makes us humans grip the steering wheel a little tighter. But just running simulations with a bunch of AIs driving around isn't the full picture. To really, truly test this system, they had to introduce the most chaotic variable you can possibly think of: a human driver. They did this with something called a human-in-the-loop test. Basically, a real person could just jump into the simulation and start controlling one of the cars with simple keyboard arrows, forcing all the AIs to suddenly react to a genuinely unpredictable human in real time. All right, so this is it, the moment of truth. After coming up with this whole new way to train AIs, giving them a coordination superpower, and then putting them through a virtual driving nightmare, did any of it actually make a difference? Well, the answer comes down to one really, really important number: 35%. And what that 35% means is incredible. The AIs that were trained to work as a team, the CMARL agents, had up to a 35% reduction in collisions compared to the AIs trained the old-fashioned way, all alone. In the world of traffic safety, that's not just a small improvement, that is a massive leap forward.
So, what does a result like this actually mean for the future of our roads? What's the big picture here? The takeaways are pretty huge. First, it just flat out proves that teaching AIs to be teammates makes them safer. What's even cooler is that the AIs started showing what are called emergent behaviors. They started to learn things like yielding and merging cooperatively all on their own. This whole project also shows that we need these kinds of complex multi-car tests. And ultimately, it tells us we are on a real path toward making autonomous vehicles that can handle the messy human reality of our roads. And it's always important to know where great ideas come from. All of this incredible research was part of a master's thesis by Venkat Shavan Nagabhushana at SRH University in Berlin. Just a powerful reminder that game-changing work can come from anywhere. And all this leaves us with one last big thought. We've just seen how we can teach what are essentially isolated, rule-following machines to become cooperative partners on the road. So if cars can learn to work together with us in one of the most complex, chaotic things we do every day, what other parts of our world could be totally transformed by teaching AI the power of teamwork?